Hello and welcome. Today I'm going to be talking about the simple 12-volt relay, how they work and what purpose you can use them for, particularly around a car or automotive purpose. For some reason they seem to be quite a mysterious little device, but hopefully I'll explain very simply and you'll get a good understanding and find some very good uses for them. Stick around for that. Okay, before we get started, I'm not going to go through a lot of technical jargon or formulas or electronic formulas or anything like that, but there are a few things you need to understand to actually understand this video, and it's going to be very simple. Okay, firstly, the power. We're going to be dealing just in a DC power, volts, DC direct current, which is just a battery voltage. Okay, the current is the flow or the amps, so how much actual power gets put through this circuit, and that's a really good reason why we do use relays. Next thing is your battery positive is going to be represented by a plus sign, and a battery negative is going to be represented by a negative sign. The other thing is ground or earth. Now, normally in an automotive situation, a negative for a battery is connected to the chassis, and that's commonly called an earth or a ground. And that means that when we power devices, we can then put the negative side of that device onto the chassis and it just completes the circuit. Now that we understand how the actual power and currents work, then in relation to a relay, I'm using just these simple box relays. They're 12 volt. They come in different sizes, smaller, bigger. The pins may be in a different arrangement, but I just want to explain the simple technology behind a relay. Okay, so in a 4-pin relay, you have a choice of two. One is normally open, and that means that sitting there without activating the relay switching mechanism inside here, the current flows into the relay and it's stopped. There's no connection to actually allow current to flow out. That's a normally open relay. A normally closed relay, again without activating any switching within it, normally closed means that if you put power to the relay on one end, it will flow out the other side without any restriction. So what that means is, with a normally open, if you want a circuit to actually work something, then it will close and the power will flow through. If you don't want it to do it, you don't switch it, nothing happens. Normally closed means that you have to actually switch this relay to disconnect the circuit. We have a 5-pin relay as the next part I want to explain, and that basically is like a changeover. It has one way in and two ways out. So if you have it sitting there normally, you can switch it either way. So you can have the power going in and constantly the power will flow through that circuit. When you operate the relay, that switch throws down, it disconnects that circuit and reconnects that circuit. So you can see in a changeover or a switch relay, you've got both. You've got a normally closed relay and a normally open relay in one unit. So you can actually use one of these to do both those jobs, but normally, and I'll explain later, there's some good ways of utilizing this kind of a relay. Right, now we move into the actual pins of a relay. Now we'll go over 5-pin and a 4-pin, and normally what you'll find is on a decent sized relay, you'll actually see the numbers printed next to the pins. The 30-pin is the actual input of the main circuit. And then you have an 85 and 86 on both relays, which is the switch circuit. You put power onto one, earth the other one to the negative, and that allows you to open and close that switch and operate the gate, so to speak. On a 5-pin relay, one of these pins, an 87A, will be normally closed or normally open, and you'll have to decide or identify that in the relay itself. On a 4-pin, you can get a 4-pin normally open relay or a 4-pin normally closed relay, and the continuance of the circuit will be connected to the 87-pin. And that's how you distinguish what pins are used for what in a relay. Okay, now we get into the sort of circuit that a relay can be used for. So you've got to think of it like two circuits that are totally independent. What you'll have here is a battery powering a driving light. Think of a relay like a gate, that you're using a switch to close the gate rather than push the gate closed yourself. So what happens is, from the positive power, the power flows up into the relay on the main circuit, but it's disconnected. This is a normally open relay. Now what happens is, on a second circuit, the power flows up to a very simple switch. It might be a little 5 amp switch or something small that can't handle a lot of current. You switch that on and it sends power to a little coil inside the relay. What happens then, because that coil is earthed, it has a complete circuit, it then closes that gate and connects the main part of the power to the driving light, which is earthed back to the negative. That's as hard as it is and as complex as it is. These two things, the coil and this switch, are independent. They don't connect in terms of electrically, but that's all. It could be just a plastic little pin, or if you want to think of it that way, that's probably the easiest way. All it does is push down, connects the circuit. When you flick the switch off, the pin retracts, pulls the gate open and disconnects the circuit. That's how a relay works. Right, we showed you in that previous part of the video how we could just operate a driving light. Most of the driving light kits you buy come with a full loom, and you'll see there's a switch and a relay within that loom. Another prime use for a relay, because a switch won't allow a lot of current to pass through it without either burning out or restricting the actual voltage. So what happens is we put a relay in a starter motor circuit. So you can consider this switch your key, and what happens is battery power is supplied to the switch, which then operates the coil within the relay. Now you'll see that I've negatively connected all of these points to the chassis of the car so they can finish the circuit. But what we have here is the relay being a lot more capable of handling bigger power and not restricting voltage, happens that when you actually operate the relay, it closes that circuit and puts a full 12 volts with good current, no restriction to the starter motor, allowing it to get a full source of power and start your car. That's the prime reason for a relay, is to give that device that you're trying to operate the maximum amount of current it can give or get, and the full 12 volts or more if you've got a bigger voltage. Okay, now we're going to add a little bit of complexity to this circuit. What we're going to have is a relay that, when it's operating the starter motor, makes sure that if the headlights are on, they get disconnected. So all your power and your amps are going straight to the starter motor, allowing it to start the car. Right, what we have here is a changeover. We've moved this relay into a changeover situation. So when we are not starting the car, it is connecting through to the switch of the headlight relay, which is normally open. So when there's power to this headlight relay, the circuit is closed and the headlights go on. What happens now is, if we turn the key to start the engine, what happens is this relay disconnects the headlight circuit, connects the starter motor, and by doing that, it actually cuts power to the coil relay in the headlight and therefore opens it and disconnects the headlight, therefore turning off the headlight. So the situation you've got is starter motor gets all the power, headlights are disconnected even though the switch is on. To check if the actual switch part of the relay is working, you need a power supply or a battery source, the same as the relay capacity, so 12 volt in this case. What you do is put a negative to one of the pins, 85 or 86, and touch power to the opposite side pin, and you'll hear a click. That way you can tell it's working. Once you've checked the switch, then you have to check whether the main circuit has actually connected when the switch operates. So I've used a multimeter which beeps when there's actually continuous of the circuit. Well, I hope that's given you some insight and some understanding on how a relay works, and maybe given you some thought for some interesting projects of your own. Understanding relays has allowed me to completely custom build a electrical loom for my Mustang project, and the Mustang project video will be coming up in a little while. But yeah, hopefully that's given you a bit of an insight.